In this video, we are going to study time series decomposition with a classical method in Python using Jupyter Notebook. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into the web browser where the Jupyter Notebook is located. So the first step within the video regarding the Jupyter Notebook is that we need to insert a new cell below, and we do so by clicking the Insert Cell Below button. And the first step regarding the code is that we need to import the corresponding packages. Therefore, we comment this as step 1, packages. And we are going to import pandas as PD. We're importing pandas for data frames. Then we're going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.tsa.api as TS. We're importing that feature from statsModels for time series decomposition. And last, we are going to import matplotlib.pyplot as PLT. And we're importing that feature from matplotlib for the corresponding chart. To run this code lines or this cell, we can either click run or we can press Shift Enter on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named mData, model data underscore obj or object, which is equal to, here we're using SM feature from statsModels.data sets.get underscore r dataset, and we open parentheses. First parameter, which is data name, equals to, and within quotations we have air passengers, comma, package, equals to, within quotations, datasets, comma, cache equals to true. So what we're doing here is the following. We're downloading air passengers object from datasets R package, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within mData underscore obj object. Therefore, we're going to create a new object named mData with only the data, therefore equals to mData underscore obj, and we're going to get its .data attribute. And we want to convert this into a pandas data frame. So we overwrite mData equals to PD or pandas.data frame, and within we have parameter data equals to mData, and we're going to select its value column, and we're going to set its index with .set underscore index, and within it the parameter PD or pandas.date underscore range, and within it we have start equals to, within quotations, 1949, comma, end equals to, within quotations, 1961, comma, FREQ or frequency equals to M or monthly frequency. And now we want to visualize part of this data, and we do so with print and mData. We're going to select its head method, open and close parentheses. So to run this code lines or this cell, now we're going to press Shift Enter on the keyboard, and we can see part of this data, specifically the first 5 rows of data with the corresponding dates, and the value, which is monthly airline passenger numbers in thousands. If you want to read the full documentation of this data, you can do so with print, and from mData underscore obj object, we're going to get its .2 underscores doc 2 underscores attribute. So to run this code line, we press Shift Enter on the keyboard directly, and we can see the documentation below. Air passengers are documentation, and as mentioned previously, monthly airline passenger numbers in thousands from 1949 to 1960. So now we're going to continue with ranges delimiting. And we're going to create 2 ranges, a training range for model fitting and a testing range for model forecasting. So let's begin with the training range. We create the object named tData, which is equal to, and from the mData object, we're going to select from the beginning of the time series all the way to the end of 1958, therefore 1958-12-31 or December 31st of 1958. So the training range is going to be the first 10 years of data from 1949 to 1958. And then we have fData, which is going to be the testing range, and in this case, again, from mData object, we're going to select from the beginning of 1959, therefore 1959 01-01 or January 1st of 1959 all the way to the end of the time series. So the testing range is going to be the last 2 years of data, 1959 and 1960. In this video, we'll only be working within the training range. So to run these code lines, we press Shift-Enter on the keyboard, and the following steps we want to visualize the training range data within its corresponding chart. So we comment this as chart, and here we'll be using plt or matplotlib.plot, and we include t data within it. Then we have plt.y label, that's the vertical axis label, and that's going to be air passengers. Then we have plt.x label, that's going to be the horizontal axis label, that's going to be year. And last, we want to visualize the chart, therefore we have plt.show open and close parentheses. So to run these code lines, we press Shift-Enter on the keyboard, and below we see the chart being printed. So we have air passengers on the vertical axis, year on the horizontal one, and the solid blue line, which is the training range data. So now that we have the data ready, we can continue with step number 3, which is time series decomposition. And as this is just a title, we press Shift-Enter on the keyboard, and in this video we are going to study the classical method. And for this, we're going to create an object named TSDEC, which is the training range time series seasonal decomposition, therefore equals to, here we'll be using TS feature from stats models dot seasonal underscore decompose function, and within it we have the following parameters, which are x equals to t data or training range data, model equals to, and within quotations, additive, comma, 2 underscore cited equals to true. So regarding these parameters, model equal to additive is because we have additive seasonal component, and 2-sided equals to true because we have a centered moving average. Notice that we need to check whether additive or multiplicative classical seasonal decomposition by moving averages is needed within training range time series seasonal decomposition that we are studying here. Also, notice that ranges delimiting and time series decomposition function parameters were only included as educational examples, which can be modified according to your needs. So now that we have this time series decomposition with classical method, we want to visualize it within its corresponding chart. So we have tsdec.plot method, and below we want to show it with plt.show open and close parentheses. So to run these code lines, we press Shift-Enter on the keyboard, and we can see the time series decomposition through the classical method chart being printed below. So at the top, we have the actual data from the training range. Below, we have the trend cycle component. Below, we have the seasonal component. And at the bottom, we have the remainder component. Okay, so with this, we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.